I'm Jin Zhang with CA Technologies here. I'm delighted to have this opportunity, joined by my fellow panelists here, to have this wonderful discussion. Now, what I'm going to do here is this is going to be a discussion. You're going to quickly find out the three of us coming in from very different paths and background, but all share some amazing passion for what we chose to do. And I have to guess, for many of you, the reason you're here is because you share the same passion, or this is coming up high to your ranking list. So we really want to be candid about this conversation, where this is not to talk about a general diversity topic. This is not talk about a wishful thinking. We want to share with you our lessons learned and some key principles, right? Whether it's things we've tried out that worked well for us, did not work for us at all, or things that we've been experimenting and coaching as we lead our teams and working with our mentees. So with that, I'd like to actually have a very quick introduction about my fellow panelists here, and then I'm going to let them tell you a little bit about themselves. So my introduction will be focused on the non-unusual part of their bios. First, I have Jerry Overton here to my right. Jerry is the Chief Data Scientist from CSC. One thing I want to tell about Jerry that I wanted to share with the audience here is Jerry has a very unusual career path to where he is today. You know, he was not born and designed to be a data scientist, but he figured out his way, and he's having a heck of a great time. If some of you have already checked out the O'Reilly books, you will look for the data science books authored by Jerry there, and certainly check out his blogs. A lot of interesting stuff around data science. So both during our discussion and later on with Q&A, make sure you ask questions about how he got there and what are some of his biggest learning. And with that, I also have Michele Chambers here. Michele is the Chief Marketing Officer for Continuum Analytics. However, the introduction I want to highlight here is I've known Michele for a long time, and the things she does is so dramatically different from one end to the other that she never ceases to amaze me. It would be, running a sales team. It would be doing a strategy, a major strategy tackle. It would be, leading a brand new startup to be the CEO and the president, or to open up an entire different market that just didn't simply exist before she got there, right? So her approach and her determination is something I really want this audience to be able to get a sense, and why that's so relevant in this data career in particular that we're passionate about. So with that, let me quickly have them do self-introduction, tell you a little bit more about the bio part, and then the key things they wanted to make sure the audience know. Jerry?
Okay. Hi, my name is Jerry Overton. I'm a data scientist in a company called CSC, Computer Sciences Corporation. It's a really large software consulting infrastructure company. I do a lot of internal projects, and my path to becoming a data scientist wasn't like the traditional path. So I didn't go through algorithms or even mathematics. I started out as an architect and then moved into a market research division in our company. And from there, we decided that we were going to start data driving what we do. And because of that, there was a role to transform the group, or at least part of the group, into data science. I took that on. That's how I became a data scientist. So when you hear me talk, I'm really not going to be talking a whole lot about, I don't love the tools or even the techniques. What I love is getting to insights. So you're going to hear me talk a lot about the scientific method, about discovery, about things like that. It's kind of different than, at least what I've read. When I hear about data science, it's usually about, a specific technique. So that's really my particular slant on things.
Thank you for that. Michele?
So hi, everybody. My name's Michele Chambers, and I started out my career as my undergraduate degree in computer engineering, and I was designed to build large-scale systems machines, and was very talented at it, but looked around at the first company I worked at, and there were 3 of them, and there were hundreds of software developers in the organization. And so I chose to go into software development, so that way I would never starve, and I'd always be able to take care of a family when eventually I had a family. So I've taken a long circuitous path in terms of everything from hardware to software to solutions to working with advanced analytics now for almost 20 years. And while I'm not a data scientist, what I have had the honor of working with is with some of the most brilliant data scientists on the planet that exist. And my specialty really was bridging the gap between their brilliance and communicating with what I would call mere mortals, people like me, who could translate the technology and the application of advanced analytics into business insight, into driving value for an organization out of using these techniques with their data. And so that's sort of my path along the way. So thank you for having us here.
Thank you, Michelle. So we're going to get started. We have some topics we wanted to go through, and then we'll open up for Q&A. And hopefully, by outlining the topics we plan to cover, we'll get a quick, confirmation here about whether we're on the right target, about the reason you're here, right? So the three things we want to cover. First, we want to touch on technology. We would not be here if we're not all in love with the technology, especially the rapid technology advancement related to data these days. But it's really key for us to talk a bit about technology because this are actually indicator of those key trends and the opening of the opportunities, right? So we're going to touch on opportunities, and then quickly we're going to move on to roles. Why? New advancement of technology has opened up new roles for us. And now we know the roles, knowing that we're generalizing this as a data career, it definitely does not equal to data science only, right? Opened up all kinds of roles. Then the third part is where we're going to spend the most of time, where the three of us are going to talk about diversity. Look around this room and look at us here. Just look at each other. It is obvious that we bring in a very diverse set of background, where we come from, the kind of education, the value system, our unique strength. And the key thing for this panel is to share with you how we see the data career has really opened up with these new role definitions and can be significantly enhanced with the awareness of diversity. And we're going to raise a lot of examples, and keep in mind, these are not your general definition of diversities. These are going to include the methodology and approaches Jerry is going to talk about, and these are going to include a total different team formation that Michelle would talk about. So with that, first one, technologies. Data has really changed. The biggest thing I think we all started to feel is data used to be something that happens in the lab, in the back end, right? Offline, you run a model, very typical in our pharmaceutical industry. Wasn't that like what, average of 10 years for a new drug to come out, right? Tons and tons of lab experiment, but completely invisible to us as consumers, as users. But look at what's happening today with data. Data is no longer in the back end. It is front and center. Pull out your device here. Are you getting push notifications? Are you getting location-aware reminders? Are you getting news feed based on your interests and preferences? So what we have now is data-driven applications. That data is no longer something to help you with capability in the back end, but rather running it real time and directly impact your user experience. So with that, I know this has really created sort of this new currency, right? There is now the saying of data is the new currency. And I know, Jerry, in your field, especially in CSC, you guys have done a lot of work regarding how data has becoming the new currency and how you see that changing your business. Can you talk to the audience here about that?
Yeah, sure. So, working in a consulting company, I get exposed to a lot of different things. We get asked to do a lot of different things for a lot of different domains. And what I found is that being data literate has given me a place at tables that I normally wouldn't get a place at. So, late last year, I was working with our group in Australia on, they have these huge mines. Mining is really big in Australia, and they have these huge vehicles. And they wanted to know what is the biggest indicator of brake failure. And I worked with them on that, and I was able to sit down with these engineers and talk about some of the leading causes of brake failure. Now, I'm not a miner. Later on, earlier this year, I sat down with the VP of HR and talked to her about what are some of the high risks that we have in terms of our talent pool, the risk in getting our talent pool and retaining our talent pool, and where are some of our dark spots coming up in the future. Except, I don't really know a whole lot about running an HR department. Just recently, even coming into this session, I was on a call with the VP from our consulting group, talking about what markets we should go into. And again, I don't know how to run a consulting group, but what I do know is how to take data, how to take a hypothesis, and use that data to tell you whether or not it confirms or refutes a hypothesis. And it's the application of the scientific method, the best method that we have for figuring out what the heck is going on. And that's a problem that everybody has, is just trying to figure out what's going on. Having that skill is very transferable, and it becomes a currency. Being able to speak data gets you a place at a lot of different tables, and it's been great for me. That's really why I recommend it for everybody, no matter whether you're a data scientist or not.
Excellent. Thank you, Jerry. So takeaway for the audience here already, right? Remember, hold this pass. This currency says data. If you are not sure how to get yourself a seat at the table, try that one, right? This is a proven experience from Jerry here already. The next technology trend, which is also key, is open data science. And this by itself, can be an entire topic, and we can probably do a half-day tutorial about it, right? But I'm going to let Michele talk about open data science and talk about how that's really changing the dynamic of the data career here.
So when I started my career, you had mostly proprietary software, and you had these very monolithic environments. And what you see happening now, and big data really, and Hadoop, really fueled the growth of that, was you saw a lot of open source technologies around data. So there's a big community. By our estimates, it's about 15 million people that are in the R community. And then you see like the Python community, and you see that there's about 30 million people that are part of the Python community. And you see every day these open source communities just growing and thriving, and it really becoming very viral. Except what's happening a lot in open source is you still have an approach that's fairly locked in. So it's using new technologies, but you don't have all the technologies being treated as first-class citizens. So while there might be some interoperability, they're really sort of recreating monolithic stacks. And so what you're starting to see now is that open source is starting to eat the world. And what you're seeing is this growing trend towards open data science, which is really about utilizing the open source technologies for data analytics and computation and bringing them together into a connected ecosystem that allows you to have really a big tent. And the reason that that's so critical in terms of technology is, as Jerry was saying, you have so many different people that are using a scientific approach. And it's not a one-size-fits-all. You don't have just data scientists. What you see is that there are people that are doing data engineering. You have DevOps. And so what you need to do is sort of open up the tent and invite everybody into the tent, all the different open source technologies, to really enable and empower the entire modern data science team. So that's what I see happening, and it's a big shift in the marketplace that's starting to unfold now.
Awesome. So we talked about the new currency, the big shift, all contributed because of technology, and now we can look at the roles. In fact, I think Michele has prepared, this is what open data science is like, right? Initially, if we think about data scientist has this beautiful artistic paintbrush, but now it's all over. And when it's all over, the impact you get to have is significantly wider. And from this here, it also helps us to understand how come we start to have a lot of non-traditional roles and a non-traditional path. So Jerry, you had showed me a great picture illustrating how you got to data science and the path you took, how untraditional, unconventional that is. Do you want to share that picture?
Sure.
All right, let's bring it up.
Okay, so I think I talked about what's on the left there, my eventual transition into data science, right? So my role, there's a few paths that you can take. I think the one that a lot of people take is, if you want to become a data scientist, well, let me ask, how many people here are data scientists? Okay. Anybody want to admit to being to an aspiring data scientist?
Yes.
Okay, cool. All right. So there are different paths into it, and to each his own. The path most taken, I think, is the one where you take a bunch of courses, you get the certification, you apply for a job that has data science in the title, and you get through the gatekeepers there. But the way that I did it was I essentially transformed my role as I transformed my own skill set. So as I became more data-driven, I sat down, I talked to my boss about making the job more data-driven, and at some point, I was doing more data science than I was not. And then, that kind of, we paved the road around that goat path. Doing it that way, my skill set ended up looking a little bit different. So I read a lot of blogs and, things from other data scientists. It's very interesting to me. But a lot of times I feel alienated because, I just don't feel like, that is my experience. So, I see a lot the diagram on the right where it talks about the combination of computer science, domain expertise, and mathematics. My particular skill set looks a little bit different. For me, computer science, even though I came up in computer science, became a software architect, my skill is more towards professional data science programming, which is kind of like controlled hacking almost. Instead of the domain expertise, right, it's really an agile experimentation. What I've found is that it's actually more useful rather than being a domain expert yourself, is being able to communicate very rapidly with domain experts, because someone always knows a lot better or a lot more than you do. And being able to do agile data science, connect with people, figure out where you're going, and make course corrections along the way, I've found to be even more useful than cramming my head with a lot of domain expertise myself. And then in terms of mathematics and statistics, of course, you need the mathematics, you need the algorithms, but what I've found is that they're more tools than anything. What you really need to be able to do is validate hypotheses, right? Look at data, compare it to the hypothesis, and tell whether or not the data backs up the hypothesis. So that's really kind of those two slides are a summary of my skill set and my path into the skill set. So it's a little bit different, but I make it work.
And that's really what we're here for, especially for the incoming team members here who wants to be either a data scientist or get into the career. You shall not fear, right? We've had proven success here to say these are actually the ways to get in and actually can get very effective. In fact, the other thing I would add to Jerry's stories here is if you look at the business we're in today, the data-driven header has becoming such big deal. Looking at product management, that's the field I'm in, right? We're talking about data-driven product decisions, meaning I want to precisely know what my customer, what feature they've used, what's the path they've taken, so I can make proper product investment and prioritization decisions. We also have data-driven marketing. Michele knows this really well, right? As we drive our demand, trying to nurture the funnel, we really wanted to have data prove to us, should we invest into this particular marketing mechanism or should we look for an alternative? Same thing for data-driven customer success, technical support, right? So interestingly, recently in one of the conversations, I had a question asking me, okay, Jin, thank you for removing my fear about, it's okay for me not to have a PhD in statistics in order to even consider this path here. But where do I start? Besides, I've been taking, classes from Coursera. I said, start with where you are today. I don't care what you're doing, but I bet you can find some data there. Define a problem that would either speed up what you're doing or deliver something that your boss needs that you cannot have yet. Do some volunteer work, dig out a couple weekends, and burn it out. You're practicing your data and analytics skills, and that is really the best way, exactly as proven in Jerry's experience. He created the role, right, because he started with data. Again, that currency we talked about in lesson number 1.
Right, and what you said was key, those small projects, being able, instead of having this goal 2 years out, okay, when I become perfect at this and I know about it, I'm going to go ahead and make my entry into the marketplace. This is improving and changing your skill set in small chunks, small projects, just whatever you can get your hands on.
Yeah, and that also ties into the number one criteria for success, the predictor for whether you'll be good at data science is curiosity. So both of you have highlighted, right? You started out with, from your software architecture, starting to look at data, you were curious, and you started to evolve from there. The same thing, Jin, when you were just describing it, right? You start with the data, and you start asking questions and probing, right? And that is the most impactful skill that you can have to really make that journey into data science today.
Excellent. Excellent. And with that, Michele, actually, why don't you then tell us a little bit more about some of the specific roles? Because we've talked about how the roles are actually not everything that's set 100 years ago as our traditional roles. So tell us about some of these new roles.
So as we talk to hundreds of organizations, I'll start out sort of at the macro level. And what you see happening out in the marketplace is you have your traditional IT organizations that are managed and controlled by a CIO. And that really has gotten to a place where it's very mature and it's really about operationalizing the business and reducing cost, being very cost efficient around your IT infrastructure, all your software deployment. And so as we look at the first generation of analytics, the more traditional analytics, you see that that's really the number one criteria and mission that the CIO and his team typically are on. Then what you see is the CEOs now are going off and hiring chief data officers. And the chief data officer's concern is very different. Sometimes the chief data officer reports directly into the CEO. Sometimes they're reporting into a line of business, depending on the size and scale of the organization. And the chief data officer has very different concerns. They're looking at data as currency, okay? And if you also follow Doug Laney with Gartner, he actually, post 9/11, because in the 9/11 catastrophe, so many businesses lost real valuation because their data was destroyed, okay? And they did not have an ability to recover from that. So he is on a mission to take data and actually put it on the balance sheet, because today it is an asset no different than if you buy like a mining machine, right, that you have to maintain. So you see what's happening with the chief data officer. They're really concerned about the data, the provenance, the security, the lineage. That's really mostly their mission. You're starting to see organizations create chief analytic officer roles. And the difference there is that the chief analytics officer typically has an analytics background. So they typically are a PhD, and their charter in the business is to help the business be a liaison to exploiting their data, to actually driving the insights and the business value and embedding it into operational processes in the business, so that they're not making just ad hoc analytic decisions, that they're making repetitive decisions on a daily basis that's all about evidence-based decision making, as Jerry's pointed out. So that's what you see sort of unfolding in IT and line of business. But then you see now a lot of these, what may sort of seem like rogue groups or institutionalized shadow IT, people think about them differently. And they come under many, many different names. So you'll see centers of excellence, you'll see lab teams, you'll see emerging teams, advanced technology teams. And what these teams are really chartered with is going out and understanding the plethora of open source technology that's available and understanding how to actually bring it into their organization, understanding is there value in it, how do they actually bring it in and sort of tame the anarchy for their enterprise that is typically associated with open source, right? Because what's great about open source is that you have constant innovation. And that's a bit scary when you're in an enterprise, when you've had a lot of governance and a lot of control. So their charge is to figure out how to leverage it for the business, and typically they will build prototypes or early stage concepts for the business to prove out value, and then for that value, they'll help IT with bringing that technology in-house and actually adopting it in a way that they can control that fits their processes. So those are sort of the organizational, the differences in the roles that you see. And it's hard, right? Because, you know, some organizations, they have a chief data officer that does happen to be a PhD, and so they play sort of a dual role, right? But in general, that's what we see emerging in the marketplace.
So we definitely see here, you know, technology is disrupting, created a lot of new roles or new definition and new expectation of the roles that wasn't, quote unquote, the same as the traditional ones before. And now this is a perfect opportunity to introduce why diversity, right? Why we want to promote different people coming in, taking these different roles with a different path, because each in that fashion would bring in something unique to this puzzle here. In fact, with that, I'd like to start first on the benefits, right? Why we think, in this case, having a very diversified, not only talent pool, but also the path and the source is in particular beneficial. I will give a particular example, right? I think it's very clear that if you look at from a gender perspective, men and women approach problem solving differently. We tend to take a different approach. We tend to focus on different aspects of things. So in my team, for example, what I've noticed is if we present a problem, we're all this kind of go-getters, right? So immediately the team in a brainstorming session or, you know, stand up, we start to jump into, let's do this, let's do this, let's do this. However, one example that really reminded me is I have Laura on the team. One time after everybody went through, you know, problem solving ABCDE already, she came back and asked, was the problem about this particular customer that we needed to, you know, recover and fix, or was this problem really about the competition that's out there that we're afraid will take away this customer? I remember the quietness in the room when she asked that question. Right? Again, that illustrates how different her thinking process was. She did not jump to the conclusion, but she was able to remind all of us step back a little bit, because by answering that jointly as a team, we actually had better clarity and focus, and we were able to tackle that in a much more sustainable way. So that's just a very common example I'm sure many of you would run across in your team when there is diversity involved, right? Jerry, I know you actually have some unique examples that's beyond the obvious, you know, the obvious of gender, race, you know, whatever that seems to be more on the surface here. Do you want to share a little bit more about that?
Sure. So I'm really concerned about diversity in the data field and in the data science field, but I didn't realize that that's what I was concerned about. I talked to our corporate philanthropy, the lead of our corporate philanthropy office, and she gave us this slide, this iceberg slide. And she's sitting around talking to us about, you know, what does diversity really mean? And there's surface diversity, like, you know, what people look like, and, you know, male and female, and where they come from. But then there's all this stuff below the surface. And the thing that was really interesting to me was the thing that I think about a lot showed up on this iceberg, thinking styles. I am really concerned about the diversity of thinking styles when it comes to data and data science. And what I mean by this is, I mentioned before, I read a lot of blog posts, and, you know, I try to connect with as many other data scientists as I possibly can. And one of the things that I find is that the work that's out there generally follows the same path, where it's very tool-centric, it's very deductive, where, you know, you get a lot of you know, deductive statements followed by a lot of caveats. It's pretty hard to follow. And that was one of the things that was a barrier for me getting into data science, because, you know, I originally thought, well, yeah, I don't really think that way. I'm not sure if I have too much to contribute to that. I'm actually more of a computational thinker. So, you know, instead of writing equations, I throw together, hack together a program, run it, and see what happens. I found that there's a place for that kind of thinking. I realized, you know, working on projects, hey, I can actually contribute. I can actually come to reasonable, testable conclusions using my thinking style. And I've started connecting with other people who have different thinking styles. Some people think analogically. Some people think in terms of pictures or whatever, and we are really missing that. And what I would like to see, if you don't take away anything else from this panel, what I'd like to see is, as the aspiring data scientists become data scientists, if you follow a different path, if you find that your thinking is different from the stuff that you see out there, put yours out there. Say something. We need that diversity of thinking. And we need that diversity of thinking to be visible so that other people will look at it and say, well, I don't actually think that way, but, I can do the scientific method. I think this idea holds in reality. Let's test it. Let's see. We need people like that.
And I think, Jerry, what you brought up is such a key thing is it takes courage when you think yours was less popular, not obvious, abnormal, to bring that out. But when there's more and more of these unique thinking, unique methodology, unique thinking style coming out to the surface, that becomes the new norm. And that's really what we felt extremely hopeful that it would significantly leverage, elevate the entire data career and all of our capabilities here as a platform. Now on that one, Michele, I'm going to come to you. I want to be conscious of our time, and time is actually running fast on us, so I'm going to speed things up a little bit. Michele, I know you have a very unique perspective where when we talk about data career, you believe strongly that algorithms are not all. And for that reason, I know you specifically wanted to talk about the approaches and the scientific approaches there. So tell us more, please.
So one of the best sessions I've been to at any Strata conference started by Jerry Lin, who's a professor at the University of Maryland, who happened to have been on sabbatical at Twitter at the time. And he started his session and he said, if you've come here to learn about algorithms, I'm going to sorely disappoint you. You should leave now because I'm not going to talk about algorithms, okay? And what he did was he talked about actually applying advanced analytics because his contention was that every algorithm that we actually need is already in existence out in the world, okay? And his approach was, we have more algorithms and algorithms implemented than we could possibly use in our lifetimes of a data science journey. And so that made me start thinking about the application. And what you see happening today with modern data science teams is, if you look back, there was sort of an era of a very statistical approach to all of the analytics, and that it was a one-size-fits-all of statistics is the only way to look at predictive analytics. And then sort of came along data mining, and data mining was an iterative approach and a data exploration approach. But because it could not be systemized as easily, data mining really didn't take off. And now here we are in the big data world, and in the big data world, what are we doing? We're talking about exploration and discovery, which is very much a crisp and an agile approach to building out predictive models. And so as we start to talk to more and more people around big data, what you see is that they are using this, more people are trying to use a scientific approach. And then you also see in parallel some of those same teams using quick to fail techniques, okay? So techniques where they put something out very quickly, and the idea is let's try a hypothesis and let's figure out, is that going to be a reasonable approach? And if it's not, let's let it fail before we go and build this huge project and put all this time and money and resources into it. Let's just learn really quickly and decide whether we're going to evolve that or whether that we're going to move on to another approach. So the quick to fail and experimentation approaches are extremely popular now. And when you have larger scale data, it just lends itself to that very easily. What you also start to see is a resurgence of really the crisp methodology around data mining, and which really blends both of those in a very nice fashion so that you are exploring the data, you're based on your curiosity, you're coming up with hypotheses, right, so that you can test them and that you can iterate very quickly on that. And what I've noticed is that in the modern data science teams, because there are multiple, it really is a team sport. So you have data scientists, but you also have data engineers, and you have business analysts, and you have DevOps, and you have developers, all trying to collaborate, and they all come from different backgrounds, different perspectives. And rather than it being a one-size-fits-all approach, it's really each one of these team members will take different approaches, and the healthiest organizations, to your point, Jerry, right, are the ones that don't have that one-size-fits-all, that they're healthy because they have different ideas and they can challenge each other, and that way they're not working into like a group think around their data science. So that's what I've seen in terms of the evolving roles and approaches.
Excellent, Michele. And I know, Jerry, on that topic, you wrote about agile data science, so please add more here.
Oh, sure. So, my whole approach is each time I came to something, that I had to struggle through, at the end of it, I would write almost like a letter to myself, or a letter to my younger self. Here's stuff I wish I knew when I had started. And then I collected it together and put it into this report that came out. But one of the things I wrote about was agile data science. So taking essentially the agile method, applying it to data science. And what it really came out is the application of the scientific method. I mean, it's really not anything revolutionary, right? The scientific method is our very best method that we've come up with for figuring out what's going on, for separating myth from reality. Take that, apply it into a business setting, you have data science, or at least you have good data science, right? That's the data science that ends up making a difference. If you do that in short iterations, come up with a hypothesis, use the data, test it, figure out what's going on, rinse and repeat, it's a very simple concept, but it ends up being very powerful. We called it agile data science and stuck it in the report, but it's really just the scientific method, a scaled down version of the scientific method.
And that's really very effective, right? What I think for the audience here, if you wanted to go back to your team, go back to your manager, and really with some catchy phrases that would really enable a successful conversation, say, I'd like to talk to you about agile data science. This will work. So be conscious of time. We got 3 minutes left here. So I'd like to get a sense from the audience if there's any burning questions from you. And if you do, I want to ask for your help by come to the mic so that the rest of the audience can benefit from your question as well. Any questions? And we're going to hang around after the session, so feel free to approach us afterwards individually. Now, just to wrap it up, we have to speed up a little bit. I'd like to wrap up this panel with one sentence advice from each one of us about, and this advice is either for our audience as individuals or things you can possibly do for the team you manage, for the mentees you coach to help grow your organization. And that's, of course, specifically around data career here. And I will start with that one. My one sentence suggestion would be, go beyond your job description. Jerry?
I'd say don't push yourself into a mold. And if data science is done right, the ultimate arbiter of whether or not you've provided value is reality itself. Did your prediction actually hold in reality? You don't really need the permission of any one person or high priestess of data science. So think how you think, act like how you act, and find a way to make that work in data science. And then once you do it, tell us about it, write about it, make it visible, so that it makes it easier for everybody else.
Yep, make it the norm. That's excellent. Michele?
So the two thoughts that I have would be, play to your strengths. Each of us know what our strengths are, and while I was trained as a computer engineer and understand how to think as an engineer, and what I learned was that my really unique gift and talent was that I could bridge gaps. And I did independent consulting for a long time. I was paid an absurd amount of money to do that. And people would ask me why they should hire me. And I would simply answer was because I could actually be a bridge and a translation. And they would always buy off of that, and it served me extremely well. And each of us have individual strengths that we bring to the data field, and if curiosity is your strength, leverage that to the hilt. So take your strength and turn it into really your unique value proposition.
Thank you so much. Like I said, we'll stick around for additional questions, but please help me with a round of warm applause to thank my panelists here, Jerry and Michele.
Thank you.